A data type is a fundamental concept of programming. Data can be a number, string, or even an object. There are different categories of data. Each category is called a type. And this type of data, or in other words, data type, tells the computer how we, the programmer, intend to store and use that data. Understanding data types is important to maintain the integrity of data that we intend to manipulate via our VBA code. In this introductory lesson, we will start with an overview of data types that are available for us to use within VBA. Then, we will disambiguate the terms variable, data types, values, and literals. We will learn how to determine the value of a type. Next, we will check out how to convert data from one type to another. This is called type conversion and is an important topic. And lastly, we will distinguish between the terms nothing, blank, empty, null, etc. These are the default values of unassigned variables. There are 5 more parts to this lesson. In each part, we will deep dive into ways of working with one particular group of data types. This table shows the common data types available in VBA. We have introduced data types over the previous 3 lessons on variables, constants, and object variables. So let's just do a high-level recap. Column 1 shows the name of the data type. Column 2 shows the range, which is the minimum and maximum value that we can store within the data type. Column 3 shows the size consumed in memory. And column 4 shows the default value for a variable that is declared with a specific data type. We can see a grouping of data types in the table. The first group is the numerical data types. Then we have boolean, string, date, variant, user-defined types, and object. Numbers, boolean, string, and date are basic data types, also called as primitive data types. A primitive data type stores the actual value directly in the computer's memory. Non-primitive data type represent complex values such as an object. These data types store references to objects and not the actual object itself. Let's clarify some terminology before we proceed. The terms data types, values, literals, and variables may seem similar, leading to confusion between them. Let's look at the following declaration and assignment statements for the variable myName. The most basic unit that we will look at is value. Value is the data itself, and in our code, John Doe is a value. A literal is a value written directly within our VBA code, and here the value John Doe is written directly. This makes John Doe a literal value. Notice the double quotes. Text values are written inside double quotes, while numerical values can be written directly. And are there values besides literals? Yes. We may read a value from a worksheet cell, and here we are grabbing the name from the cell A1. We may read a value that is generated from an expression. An expression is a combination of values, variables, constants, operators, and/or functions. Here we have an expression which joins the first and last name proxied by the respective variables. The result is the value John space Doe. We may also read a value that is returned by a function. Here we are grabbing the name which is returned by a function, which in turn grabs the name from the cell A1. In each of these 3 cases, the value John space Doe is either read, calculated, or returned. We can call all these values as return values. Back to our original code. So far, we have learned about values and literals. Next is the data type. A data type is a category for the value. The value John Doe is text data, which is a string data type. And lastly, we have variable, which is a unique identifier for a value which we can use in our code instead of directly using the value itself. Okay, now let's read out our code formally. The variable myName is declared as a string data type and is assigned the string literal value John Doe. We can use the typeName function to return the name of the data type that is stored in a variable. So let's declare a variable that is a long data type, and we'll print out the name of its type using the typeName function. Run the code, and we get long. We can even use the VarType function to return a number representing the data type of a variable. Each number is assigned a VBA constant. For example, a variant that hasn't been assigned a value is 0 or the constant VB empty. This would be useful to know when validating our input data. So let's declare a variable product ID as a variant and assign the value from cell A1. There is currently no value in cell A1, so the variant variable will be uninitialized and will be empty. And if the variable is empty, we will print out a message. Let's use the VarType function, which will take the variable name, which is product ID, equal to empty, which is represented by a constant available within this enumeration. So we will select VB empty, and let's print out a message. Let's run our code, and we get a message which would be printed only if the product ID variable was empty. If we want to know the specific type of an object, we can use the operator TypeOf. Here we have a procedure which can clear the contents of the cells within the object that we specify. If we specify a range object as the area to clear, all the cells within the range will get cleared out. And if we select a worksheet object, all the cells within the worksheet will get cleared out. And we pass the range or worksheet object as a parameter of the clear cells subprocedure. We will cover subprocedures with parameters in a separate lesson, but for now, let's see the TypeOf operator in action. We can test our logic by calling the subprocedure on a worksheet object given by the codename sheet1. Let's press F8 to step through the code. F8 to continue on. We reach the first if statement. This first if statement will check whether the object is a range object using the TypeOf operator. It isn't, so we move to the next if statement, which will check whether it's a worksheet. And it is. And so we will proceed to clear the contents from that worksheet. And let's see what happens if we pass a range as an argument. Let's F8 again. We're at the first if statement, which has detected that the object is a range using the TypeOf operator, and we will clear the contents within that range. Let's talk about type conversions. The process of changing a value from one data type to another data type is called type conversion. There are two types of conversions, implicit and explicit. Let's talk about implicit first. Implicit conversion is when VBA automatically converts a value from one type to another. Let's look at the following example where we try to add a number to a text. The variable I is a long type with the value 1, and the variable str is a string type with the text value 100. And in the print statement, we will attempt to add these values together using the plus sign, which is the addition operator. Have a think and try and visualize what will get printed into the immediate window. Run. We get a runtime error message stating that it's a type mismatch. This is correct. As per the rules for the plus operator, if one expression is a numeric data type and the other is a string, then a type mismatch error occurs. Okay. Now instead of the word 100, let's type the number 100, but still within double quotes, which means it's still technically a string. Now think about what the result should be. Let's run the macro. We get 101. How did this happen? This is because VBA evaluated this expression, recognized that we are trying to add two numbers, understood it can safely convert the text value 100 into the numerical value 100, and went ahead and performed the addition for us. And at the heart of this logic is the implicit conversion of the string value 100 into a numeric value 100. Languages such as C# and Java don't allow implicit conversion. They are called strongly typed languages. But VBA isn't a strongly typed language. This was a rather obvious example. What we now have on the screen is a more subtle example. Here we have declared two variables, one is an integer and one is a byte. 200 is first assigned to the byte variable, and then we assign that byte type value 200 to an integer variable without giving any special instructions to VBA on how to perform this conversion. As per our data summary table, a byte can hold a smaller range of numbers than an integer. So we are effectively widening the byte value to an integer value. It's still an implicit conversion though. And we can go the other way too. Now we have a double and a byte. A decimal value is assigned to the double variable, and then that decimal double type value is assigned to the byte variable. Now, a double can hold a decimal, but a byte can't. So what do you think will get printed out? Let's run the macro. We get 22. The floating point number 22.2 was converted to a whole number 22. And since double has a larger range than a byte, this conversion is called narrowing, which is basically the opposite of widening. Implicit conversions imply that we, the programmer, are not in control of the changes made to the data by our code. This can sometimes lead to unexpected results. When accuracy of data points is crucial, we should use type conversion functions to convert one data type to another. There are a host of type conversion functions available. A few are given here. Let's look at one of our previous examples. Instead of relying on VBA to implicitly convert the string 100 to a number, we can use the clong function to convert the string to a long data type. Run the macro. The result is the same, but this time we were in control of the conversion. Let's look at another example. We have two long variables and we'll assign them the values 10 and 3, and we'll print out the division of 10 by 3. Run the macro. We get a floating point answer to the division of two whole numbers, but we could print out an output without the decimals by converting the value to a long. So let's do that. Run the macro. This time we get 3. Let's look at a previous example again. If we run this macro as is, we know we will get 101. But this time, let's convert the long value to a string using the cstring function. Run the macro. We get a string value of 1001. This time, VBA recognizes that both terms in the expression are strings, and the addition operator serves as a concatenator and joins the two values together, giving us 1001. And let's look at a final example using the cdate function, which converts to a date data type. The cdate function works on all data formats recognized by a computer. So let's print out the date value, run the macro, and we get our date in the default date format. Let's talk about default values. It is possible to declare a variable but not assign any value to it. And having no assigned value can be described in many ways in VBA. We can use the terms empty, blank, nothing, zero, null, etc. Each of these has a different meaning, and each of these is associated with a data type. Numerical variables have a default value of 0, and here in our code, we are checking if the numerical variable I has been assigned a value or not. Notice the use of the equal to sign, which is the comparison operator used for numbers, booleans, dates, and strings. Boolean variables have a default value of false, and here in our code, we are checking if the boolean variable bool is still holding its default value, which is false. A string variable has a default value of a blank or zero length or empty string. We can visually represent it as two double quotes with no character or even a space between the two quotes. And in our code here, we are checking the default value of the string variable str. There are more efficient ways to check for a blank string, which we will learn in the lesson on strings. But checking for blank strings this way is the most intuitive way. Now, let's check out some interesting values which are empty and nothing. First, let's look at empty. The default value of a variant is empty. In other words, if a variant variable is uninitialized or it hasn't been assigned a value, then it will contain the empty value. We had seen this example earlier where we had used the VarType function to test whether a variable is empty or not. We can even directly use the isEmpty function, which returns true if the variant hasn't been assigned a value. So instead of the VarType function, we can use the isEmpty function and test whether it returns a true. And if it returns a true, it means the product ID variant variable is unassigned. There's no value in range A1. Let's run the macro. We get a message. We can even explicitly assign the empty value to a variant. This would be useful when we want to reset the variant value back to its default state. So now I have populated a value in range A1, and what we will do is print out that value. Then we'll reset the variant variable to empty and then check whether that variable is empty or not. Let's run our code. The first print statement prints out the product ID and the next print statement is triggered because the variant variable was empty. Next, let's talk about nothing. Nothing signifies that an object variable hasn't been initialized. We can also reset an object variable to nothing, which releases the reference to the original object. We can check whether an object variable has a value of nothing using the is operator. We have covered many scenarios regarding nothing in the lesson on object variables. Let's move on to a slightly different topic, which is the value null. Null is used when a variable contains an unknown value. In other languages such as SQL, we have the term nullable. So if an SQL column is set to a nullable with a default, the field within that column can have some value, a default value, or a null value. This is not the case in VBA. In VBA, the default value of variables of each type is clearly defined, as we have already seen. But VBA can accept a null value which can only be stored as a variant. But one thing to note here is that we will rarely encounter null values in Excel VBA. Let's see an example just for the sake of knowledge, but it's not really important. So suppose we want to get the font style name from a range object. We can use the font.name property of the range object. But this assumes that the font in every cell is the same. I've populated each cell with a different font. Let's run the macro. We get a null value, and we can test whether value is null using the isNull function. Run the macro, and the function returns a true. Data types can store different kinds of values. Primitive data types store numbers and strings. Non-primitive data types can store references to objects. We can convert values from one data type to another. Sometimes VBA does this for us. This is called implicit conversion. And sometimes we can control how the conversion may occur using type conversion functions. A variable that hasn't been assigned a value will hold the default value associated with its data type. In the next video, we will deep dive into working with numerical data types.